Alright, so here are the solutions from test number 2 in Algebra 2. The first question reads, what is the equation of a line passing through the points 1, 2, and negative 2, 5? Well, to start this, we're given 2 points. So what do you do with the 2 points? Well, we know that those 2 points are on a single line. And from that, we can find out the slope of that line. Well, if we use the equation m equals y1 minus y2 over x1 minus x2, or rise over run, we can find that the slope is equal to 2 minus 5 over 1 minus a negative 2. We see that that's plus plus, and we are left with negative 3 over 3. Therefore, the slope is equal to negative 1. Knowing the slope, we can now find the y-intercept. If y equals mx plus b, which is again the equation of a line, we can substitute the information we have. Negative 1 times 1 using one set of points, x1 equals y, which is 2, plus b. We are left with negative 1 plus b equals 2. If we bring 1 over to the other side, we are left with b equaling 3. Now that we have our slope and our b, we can write the final equation as y equals negative 1x plus 3. There is our equation of a line. When we look at our choices, we see that choice number 2 is the correct answer. Alright, looking at question number 2. What is the slope of a line shown in the figure at the right? Well, this is simply using m equals y1 minus y2 over x1 minus x2. Substituting the information we have from the graph, we see that our y1 is 0. And our y2 is negative 4. We divide that by our x1, which is 3, minus our x2, which is 0. And we are left with plus plus 4 over 3. We look at our choices, and we can see that choice number 1 is the correct answer, 4/3. Alright, question number 3 reads, find the slope of a line parallel to the line whose equation is y plus 2x equals 6. Well, the important information we need to underline is slope of a line parallel. Well, we know that parallel lines have the same slope. However, y plus 2x equals 6 is not in the equation of a line form of y equals mx plus b or slope-intercept form. Therefore, we need to turn y plus 2x equals 6 into slope-intercept form. How do we do that? Well, y plus 2x equals 6. We bring the 2x over, we bring the 2x over, and we are left with y equals negative 2x plus 6. Since parallel lines have the same slope, the slope of the parallel line has to be choice number 2, which is negative 2. The last problem on this page reads, find the equation of a line perpendicular to the line whose equation is y equals negative 3x plus 5 and goes through the points 0, negative 8. Well, again, the first thing that's important is line perpendicular. We know that perpendicular lines have negative reciprocal slopes. Therefore, if we were to start writing the equation of the perpendicular line, we would write y equals 1/3 x plus b. Why? Well, 1/3 is the negative reciprocal of negative 3. Now, once we have a starting point to our perpendicular line, we then look for things that we can plug in to find our y-intercept. What can we plug in? Well, the problem gives us the points 0, negative 8 and says that our line goes through those points. Therefore, we can use them to find the y-intercept. If our x equals 0 and our y equals negative 8, then our b has to equal negative 8. Now that we have the b and we know the slope, we can write our equation of the line. Our equation would then be y equals 1/3 x minus 8. When we look at our choices, we see that choice number 3 has to be the correct answer. Alright, so here's the second page for the solutions for test number 2. If we look at number 5, I know I have everything written out already, but we'll just go over it so we understand exactly what's going on. For number 5, it says name the vertex and the a value. So we know that this function right over here, right there, is absolute value x function. So to find the vertex, we circled it in red, and we look at our points, and we can see that our points are -1 is our x value, and 3 is the y value. So our vertex is -1 and 3. Now what is the a value? Well, the a value is the slope of the right branch. And where is the right branch? Well, where is the right branch? Well, I'll put the right branch right here, because this is the right branch. And we want that slope. So how do we find the slope? Well, we use 2 points. So we'll use the points, the vertex point, which was -1, 3, and we have that right here, which is 3 over -1, and we subtract that. We'll choose the point 1, 4. You can see that point is right here on the line. I'll circle that. It's right there. There's another point right there. So 3 minus 4 divided by -1 minus 1 gives us 1/2. So our slope is 1/2. Therefore, our a value is 1/2. So the answer is choice 2. Alright, looking at number 6, name the function. Well, again, this function is an absolute value x function, so the first thing that we need to do is find the vertex. We find the vertex to be 3, which is our x value, and 1, which is our y value, and we know that the vertex equals h and k. H is 3 and k is 1. Now, why does that help us? Well, if you look at the standard form, which is right here, I'll box it. There's our standard form. We can just substitute our vertex points into our standard form, and that is how we get our name. So we substitute the h, which is 3, in for h, and we substitute the 1 in for k, and we get x minus 3 absolute value plus 1. But where does the -1 come from? Well, like in problem 5, we find the slope of the right-hand branch. And where's the right-hand branch in this problem? There is the right branch right there. So we find the slope. So we'll choose the vertex point of 3, 1, which we put there, and we'll subtract it from where it intersects the x-axis, which is right here at 0, 4. So when we do our slope 1 minus 0 and 3 minus 4, we get a slope of -1. So where does that slope go? Well, we know that m is equal to a, and a fits into our standard form of absolute value x. So the -1 goes right there in front. I'll underline it right here. Right there is our -1. So what does the -1 tell us? Well, it tells us that the function was not stretched or compressed, but the negative tells us that it was reflected. And where was it reflected? Well, if you look at my dotted red line right here, you can see that our function was like this. But because of the negative, we flipped it over the line y equals 1, which is a horizontal reflection, and we get the downward facing lines, almost like an upside down V. So when we look at our choices, we can see that choice 2 has to be the correct answer. Negative absolute value x minus 3, absolute value plus 1. Now if we look at question number 7, if you transform the x squared function by a horizontal translation right 4 units, a vertical translation down 2 units, and a vertical stretch of 5, what is the name of the new function? Well, the first thing we should do is write down our standard form of any function. So our standard form equals a f of x plus or minus h plus or minus k. In this case, it says a translation right of 4 units. So translation left or right is our h value, and since we're going to the right, it has to be a negative. So this becomes x minus 4. Okay? Our vertical translation we know is a k value, and it's down 2 units. So when we go down, it's always minus our value, which is 2. Now our function name is x squared, so the function needs to be called x squared, and if we put x squared there, I'll zoom in and put the squared, there goes the square. Now we finish up with a vertical stretch of 5. Now what's a vertical stretch? Well, we know our a value is our vertical stretch or compression. So since a is equal to 5, we put 5 outside of the function parentheses, and we have our new name of our function. When we look at our choices, we see that choice number 3 is the correct answer. Moving on to the final question on this page, explain the transformation if you start at y equals absolute value x and move to y equals 5 times absolute value minus x plus 3. Well, the thing to do is to remember the standard form of the absolute value function. It's up here already in green. I'll draw an arrow just so that we remember. And we match up our numbers with the variables. We see that there's a plus 3. So that's our h value. What does plus 3 mean? Well, plus 3 means we move to the left. So remember, plus 3, which is right there, means we move to the left. So we know that choice 1 could be our answer. And we know that choice 3 and 4 could possibly be the answer. But if it's moved to the left by 3, we know that 3 cannot be the answer and 2 cannot be the answer. Now we look at our a. Our a is 5, which means that we know it has to be compressed or stretched by that factor. Since it's 5, it's a stretch. Above 1 is a stretch. So we look at our choices, and where do we see vertical stretch of 5? Okay, we see that choice 4 and choice 1 are still in play. Alright, so then we look at our negative x. So what does the negative attached to the variable mean? Right there. What does that mean? Well, when there's a negative attached to a variable, we know that we have to reflect over the y-axis. So when we look at our choices, we see that the only choice that is still left is choice number 1. Move left 3 units, vertically stretch 5, and a reflection in the y-axis. If we wanted to reflect in the x-axis, where would the negative sign be? That's correct. In front of the 5. If there was a negative in front of the 5, that means a horizontal reflection. But since the negative is in front of the x, that is a reflection in the y-axis. Okay, now for our short answer portion of the test. If a line passes through point 42 and has a slope of negative 3, write an equation of a line in the 3 forms. Well, the first thing I would do is to write the equations in all 3 forms. Slope-intercept form says y equals mx plus b. Point slope is, parentheses, y minus y1 equals mx minus x1. And standard form is a x plus by equals c. If we underline the parameters that we must put in, we know that the m has to be satisfied, the b has to be satisfied, the y1 needs to be satisfied, the m has to be satisfied, and the x1 needs to be satisfied, the a, the b, and the c. If we could find all that information, all you would have to do is write it in that form, and you would have a correct answer. So where do we begin? Well, if we know the slope is negative 3, that already satisfies the m. So over here we will write y equals negative 3x plus b. So we need the b. Well, how do we find the b? Well, they gave us a point on the line. They gave us 4, 2. So let's substitute those numbers in for y and x. If we substitute 2 equals negative 3 times 4 plus b, we get negative 12 plus b equals 2. When we bring 12 over to the other side, we get that b equals 14. Now we have the b and we have the m, so we're ready to write our first equation. Our first equation would be y equals negative 3x plus 14. There's our first answer. The second, point slope form. Well, they gave us all the information. We don't have to find anything. They gave us a y, they gave us an x, and we have the slope. So to write it in point slope form, we just write y minus 2 equals negative 3x minus 4. That's it. And standard form, ax plus by equals c. We know we get from the original equation in slope intercept form of y equals negative 3x plus 14. We bring the 3x over, plus 3x. We bring the 3x over, and we are left with 3x plus y equals 14. When we write it, standard form, 3x plus y equals 14. If we box our answers, I'll choose a different color. We can see our final answers. Here's one of them. Here's one of them. And there's the last one. Alright. Number 10 reads, turn y equals 1/2 x plus 4 into standard form with integer coefficients. Well, the first thing we do is write the standard form, which is ax plus by equals c. Alright? In order to turn slope-intercept form into standard form, we must bring over the half x. When we bring over the half x, I'll write on the left column. We have 1/2 x plus 4. We're going to bring over that half x to the other side. And we're left with 1/2, or I should say half x plus 4 plus y equals 4. Like so. Okay, but we're not done yet. Now, why aren't we done? Well, we said we wanted this standard form with integer coefficients. And right now we have a rational number. The negative half is a rational number. How do we get rid of the half? Well, if we multiply one whole side by the denominator, which is 2, and we realize wherever we do on the left-hand side of the equal sign, we have to do on the right-hand side of the equal sign, we are left with negative x plus 2y equals 8. Now, where do we get the 2y from? Well, we have 2 outside the parentheses, so we have to distribute. 2 times negative 1/2 gives us a negative x, and 2 times a y gives us 2y. Therefore, the final answer in standard form would be negative x plus 2y equals 8. And the final question on this page reads, write the equation for the graph shown at the right. Assume that the parent function was y equals absolute value x. Answer each step below. Well, we know that the parent function y equals absolute x, if we drew it, would be, if I draw it correctly, would be right there. So how did that function move to become this new function? Well, I gave you the steps in order to come up with the final name. So the first thing to do is to find the vertex. So when we find the vertex, we know that the vertex is right here. There's your vertex. It's at x equals negative 2 and y equals negative 1. So the vertex would be at negative 2, negative 1. There's your vertex. The a, which is equal to the m of the right branch, we can find by, right over here, m of right branch equals, we use the vertex point of negative 1 minus, let's say, 0 over negative 2 minus 0, since the line of the right-hand branch goes through the origin. And we find that the m of the right branch equals negative 1 over negative 2. So m right branch equals a half. When we think about that, since the a is equal to 1/2, which we'll write, since we'll write right there, a is equal to 1/2, we know that there cannot possibly be any reflections. So Are there any reflections? We know that the answer is no. Why? The graph looks very similar to the parent function. It's both showing a V. If it was an upside down V, then we would know that it was reflected somewhere. But since A is positive and we can see that the graph is that V shape, we know that there were no reflections. So how do we name this? Well, I'll write the standard form down here. F of x equals A absolute value x minus h plus k. That's the standard form for any absolute value x functions. And now we just input the information. We know our A to be 1/2 absolute value x. We know our h is a -2. And we know our k is a -1. Since h was -2, that becomes plus. So our final answer, or our name, we can say f of x is this function. So we can write up here f of x equals 1/2 absolute value x plus 2 minus 1. And I'll box it in as our final answer. Question 12b says, using your equation, predict the price of a 280-foot tarp. Well, how do we do that? Well, if the size of the tarp was our x value, if we plug it into the equation, we would get our y value, which is the price, and therefore then could predict exactly what the tarp would cost. So, if y equals 0.16 times 280, which is our x value, plus 0.57, our price around this over here would equal $45.37.